Hello student, I am Arnab Das. Today we continue our previous day topic, that is the oscillator. For the oscillator one, their basic block diagram is looked like this one, where A is the forward path gain, beta is the feedback gain. From this block diagram we can conclude a equation, and that is V0 by of Vs equal to A by of 1 minus of A beta. If you concentrate on that particular equation, that time here V is equal to 0 only that time when A beta is equal to 0. Why it is happen as such? Because for the A beta, when this is 1, that time 1 minus of 1, its value will be 0. So if you compare between these two ratio, that time should be Vs on that particular condition will be also 0. So if you conclude Vs equal to 0 only that condition when magnitude of A beta is equal to 1 and angle of A beta is equal to 0. This particular condition is specified as a Barkhausen criteria. Today we discuss about more detail for the Barkhausen criteria, with also how this kind of equation you got you can also able to understand after this explanation. Now you concentrate on this picture and also the explanation, by which this is more easy for understanding. So V of E, which is defined the error signal, which is the summation of Vs and the V of F, because this is the positive feedback circuit, and equation 1 is specified this one. This is the loop gain. Beta is defined the loop gain, and we know that gain is defined is output by of input. Here this is the voltage parameter is used, so beta is equal to output is here V of F. Looked at the arrow position, then automatically you can able to identify which one is used for the input and which side is used for the output. So here arrowhead is in this position, so this is input, and here this is the arrow is outward from this box, so it will be output. So beta is equal to Vf by of V of 0. So from here you can write down V of F is equal to beta into V of 0. So you can explain, or you can able to got the equation number 2 on there. V of 0 is defined as a, again you just recall, A is equal to, for this box input is V of E and output is V0. So this is output by of input. So V of 0 is equal to A into of V of E. So you just put this value in this position. Look at this one, the equation A into V of E. Now on that A of V of E, here V of E position, put the value of V of E. If you apply the value from this equation number 1, so equation will be lastly come as A into Vs plus of V of F. And if Vf value is put it from the equation number 2, you can able to got the equation number 3, that is A equal to Vs plus of beta into V0. Due to the reason of V0 is equal to A into V of E, and after putting the value of V of E and V of F, you got it the value this one. So from here, if you common the V0 for the left hand side and the right hand side, that time equation can be got as such. Now, if you want to got the feedback path gain, that time feedback path gain will be defined as, look on this block. Now we are interested to calculate the path gain. So this is the total block. For this block, this side is indicate output, this side is indicate input. So feedback path gain will be output by input. Output is here V of 0 and input is there V of S. So we just do the total feedback gain as a V0 by of V of S. So look here, this is the total feedback path gain V0 by of S. To calculate this one, we want to help of the equation. So this will be A by 1 minus A of beta. So this is the basic principle for the oscillator one. If you represent into the S domain or frequency domain form, that time each and every voltage or gain term you have to write down as a frequency term. In here this is S is defined. S is defined as the value of J of omega. So you just put this individual parameter into form of the frequency term. Here T is defined as a multiplication of forward path gain and beta is the feedback gain. This is also named as open loop gain also, and this one is represent as a T of S in this case. So we can rewrite A of F, that is the total feedback gain, in the frequency domain as a AS by of 1 minus of T of S. If you rewrite by replacing S as a J omega, that time feedback gain to the form of J omega can be write down A by of this one. So that time this is TS open loop gain will be A J omega into of beta of J omega. So condition is that for oscillation, you just recall the Barkhausen criteria where A beta should be equal to 1. So you just in the frequency domain form write down this one, because Barkhausen condition is A beta should be equal to 1. So you just apply this one in this position. So total feedback gain, which is this one, the circuit will be finite output for the zero input signal, and that time we conclude that this is oscillation is occur on there. Thus condition for the sinusoidal oscillator of frequency f0 is, what happened if we conclude that for the frequency f0, that time only this Barkhausen condition or criteria is maintaining. So omega is replaced as a form of omega 0, that is omega is equal to 2 pi of f0. So here f0 is written for this reason, omega is represented as a form of omega 0. So a into of j omega 0 into a beta into j omega 0 should be equal to 0 when the particular sinusoidal oscillation frequency f0 is occurred. So this is the Barkhausen criteria. The frequency of oscillation is slowly determined by the phase characteristic of the feedback loop. The loop oscillates at the frequency for which the phase is 0 is occur on there, because Barkhausen condition is determined as a of beta mod value is equal to 1 and angle of A beta should be equal to 0. So this one is explaining in this particular text. Now the question is that if no signal is applied as the input, that then how the oscillation process gets started? The answer is that by the noise signal, this is noise signals and the transient associated with the circuit tuning on provide the initial source signal that initiate the oscillation. So when you do the practical design for the oscillator one, there's three things you should be remember on there. That is usually oscillator are designed so that the loop gain magnitude is slightly higher than the unity. Practically it is equal to unity, but in this case little bit higher than the unity. If we design the unity loop gain magnitude, a slight reduction in gain would result in oscillation that die to zero. And for this reason, you have to do that. The drawback is that the oscillation will be slightly distorted. That is, the higher gain result in oscillation that grows up the point that will be clipped. So basic principle, how can you conclude this? For the feedback oscillator, it widely used for generation of sine wave signal. The positive or in phase, positive or in phase feedback arrangement maintains the oscillation. The feedback gain must be kept to unity to keep the output for distorting. So if you look on this basic picture point of view, that time what happened? There no input signal is applied on there. There no V of S is present on here. This is the closed loop is maintaining for oscillation process. So for the design criteria of oscillatory is magnitude should be maintain the Barkhausen criteria and total phase shift phi of the loop gain must be n into of 360. If n is equal to 0, that time it will be 0. If n is equal to 1, that time it will be 360 degree. If n is equal to 2, that time 180 degree. In such a way, phase shift will be as such. So, thank you for this lecture, and we again meet together for continuing our next topic, and that will be RC oscillator. Okay, thank you.